Hello class, these are our Algebra 2 notes. We are looking at a review on solving linear equations. So just kind of a quick little, first one's talking about what equations are, that they have to be equal on both sides, they have the same value, we can do any operation to both sides, and we say almost any because there's going to be like weird stuff. But for the most part, if you're going to add 5 on one side, you add 5 on the other, right? We do the same thing on both sides. When we're solving equations, we want to isolate the variable, and we do this by using inverse operations. That's the vocab word we're looking for. A lot of students think about undoing or canceling out, and those are good ways to think about it, but our proper vocab word would be an inverse operation. So if there's addition, we would subtract. If there's multiplying, we would divide. So our steps, it's a little tricky, I feel like, to say what we do every single time, but either the first or last step is to clear equations of fractions or decimals. And we'll talk about that in a little bit. We want to make sure we use distributive property, which removes parentheses. And we want to make sure that we combine like terms on each side. So basically what we do is first we want to make sure that we're kind of simplifying the way that it looks, right? We want to make sure that we have like x's and numbers on one side, x's and numbers on the other side. So we want to make sure we do all of our simplifying stuff so that we just have like a 5x, a variable term, and like a plus 7, something like that on both sides. Variable term, constant on both sides. And then our next step is normally to add and subtract. And I say normally because I can come up with equations where we wouldn't do this next. But to add and subtract to bring variables to one side and constants to the other. And then our last step is to multiply or divide to isolate the variable. And this again is normally. And I don't know how I feel about writing all these steps out because like I said, I can always come up with something that's not going to follow them. And so it kind of bugs me saying this is how it always works. But it gives you a good general idea. So our first example really does have a fraction. So there's a lot of options for fractions. One of them is that we could just distribute the fraction. Another is that we could use the reciprocal and multiply on both sides. Another is just to multiply by the denominator. So these are kind of our 3 different options when we got a fraction like this. So let's think it through. If I distribute, I'm multiplying 2/3 times 2, and then 2/3 times 1, really times 2x. So what would happen is we would have a 4x over 3. So I'm not going to do that because I do not want fractions. I want to work the easiest way possible. So I'm not going to distribute. The second option, reciprocal, would mean that I'm multiplying both sides by 3/2. So I'd multiply by 3/2 over here, which would be great. 3/2 times 2/3 is just a 1. 2x minus 1 would be by itself. And then I would also multiply by 3/2 on the other side. But I already run into trouble. 3/2 times 3 is just going to be 9/2. And now I have fractions again. So I don't want to introduce a fraction that doesn't need to be there. I want to work smarter and not harder. That brings us to the third option, multiply by the denominator. Now this isn't always the best because it makes a lot of the numbers larger in the equation we're working in, but it will always work. It will always clear out fractions for something like this. And I did not mean to erase that. Multiply by denominator. So my denominator here is the 3. So what I'm going to do is I'm going to multiply both sides by 3. So 3 times 2/3, 3 times 3. So if I multiply 3 times 2/3, now I just have 2. So on the left-hand side, I have 2 times 2x minus 1. On the right-hand side, 3 times 3 is 9, so 9 times 3x plus 2. So my numbers that I'm working with are all going to be larger, but I don't have any fractions, and that's what I'm trying to do. So I don't mind having a fraction, but I really want it like in the last step of my problem. I don't want it in the beginning step of my problem where I have to add and subtract and work with it all the way through. Again, we're working smarter, not harder. Now we're going to distribute. Let's see, 9 times 3 is 27x. Okay, and then at this point, this is what we've got. We did like all of our combining kinds of steps. So I have a variable term and a constant term. Variable term, constant term on both sides. That's what I'm looking for. Now I know I need to do like step 4 where I'm adding, subtracting to get variables on one side. So minus 4x minus 4x. I always want to move the smaller one, so I'm going to subtract it. That's my inverse operation. Negative 2. I don't like the way that looks. Let's fix it. Negative 2 is equal to, let's see, 23x plus 18 minus 18 on both sides. Negative 2 minus 18 is negative 20. Last step, divide both sides by 23. So my answer is negative 20 23rds is equal to x. We're leaving it as a fraction. It's fine. Okay, so there's a couple more. On this one I have 5/6 x plus 3, and the other one I have a 5/3 there. So I don't know, I don't like how close this number 1 is to the problem. It kind of looks like it's part of it. So on number 1, I would first subtract 3 on both sides. If you feel pretty confident, you could pause, try these two on your own. I kind of would think with the fractions we might not be that confident. And then I want to multiply both sides by 6/5. I want to multiply by the reciprocal. And 5/6 times 6/5 is just a 1x. X is by itself. Over here, I would do, let's see, the 10 and the 5. Let's divide them both by 5. And then 2 times 6 is 12. So a little bit of reducing fractions there. On the next one, distributing 5/3 is going to be bad. I'm just going to multiply both sides by 3. And I am going to rewrite this because I don't feel like I have a whole lot of space to work. So let's multiply both sides by 3. So multiply this one by 3, multiply this one by 3. So 3 times 2x is 6x. 3 times 5/3 is just a 5. And now we're going to distribute the 5. And then I will subtract 5x on both sides. I'm already starting to isolate them on the left, so that's really my only move. X is equal to negative 30. We really want you to show all of your work still this year in Algebra 2. So let's remember, many of us are coming from middle school, and maybe our work habits are a little bit sloppy. We really want to tighten that up. Algebra and being able to write out an algebraic problem it's a skill, right? It's like writing a paragraph. When solving an equation, sometimes we end up with an equation where the variable zeroes out or cancels. Those are all kind of math slang, but that's really what we're talking about here. And there's two different variations of this is what we're looking at. So we're kind of looking at special cases when you problem solve. So on example 1, we're going to go and distribute. We'd get 4x plus 4 is equal to 4x. And it's kind of weird. I have 4x on both sides, but I know that my steps say, well, subtract to get variables on both sides, or do something to get variables on one side. Sorry, on one side. So when I do this, I end up with 4 on the left, and then the right is just a 0, and this is not true. So whenever I get a false statement, my answer is going to be no solution. And the symbol for that is a 0 with like a diagonal line through it, kind of like that. And that means no solution. So this is because we got something that was false. So I feel like I want to highlight this right here and just be like, hey, that was a false statement. And you can only tell that when there's no variables remaining. The second one, I've got different options. I could divide the 4 out into both of these, or I could multiply both sides by 4. So we could either go the reducing the fraction route or the multiply by 4 route. I'm going to do the reduced fraction route, but both are perfectly correct. 8x divided by 4 is 2x. 20 divided by 4 is 5. And then I can see, oops, both sides are the same. If I subtract 2x on both sides, I'm left with negative 5 is equal to negative 5. And that is a true statement. So if I have a true statement, that means all real numbers are a solution. So we could say like x equals any real number. It's commonly worded that way. There's a lot of different ways to word this. You could say that there's many solutions. You could say all real numbers are solutions. And the symbol for any real number, or for the real number, set of real numbers, is that fancy looking R. So again, on this one, I got a true statement. So you're going to go ahead, and now this is where I do want you to actually try these 3 on your own. So go ahead, pause the video, try these 3. I'm not going to talk my way through them. I'm just going to kind of work them through. So when you're ready, go back and unpause and just see what happens and check your work over. So my answer on the first one was 9/4. You don't need to write this stuff over here. I just find if it's one of those things when I don't do it, someone wonders what I did. We do need to have our answers in the simplest form, but we want to keep them as fractions. So I solved 2 and 3 as well. For 2, I have no solution. For 3, I have any real number, so I put the real number symbol. You could just get away with doing symbols on those. It's okay if we use symbols. Another thing I always like to point out to students, if 0 with a line through it means no solution, that means when you're writing the number 20, you can't be one of those people that just puts lines through your zeros all the time, because that doesn't mean 0 anymore. It means something. So be really careful about that. This is just meant to be a quick review of all things kind of solving equations. So they're pretty difficult. We assume that you can do the easy ones on your own by the time you get to Algebra 2. I still want you showing work steps. It's really important. So your work should look pretty much like mine all the way through. As always, if you need help,